Well, thanks to everybody who's joining us today for this webinar. It's titled The High Cost of Inaction, How Grid Delays Undercut America's Growth. We have over 100 people today, which I'm very pleased with listening to this because we are getting closer to the holidays. But even though the holidays are here, the problems that we have and the issues that we face with the grid are not going away. We all know that large-scale transmission is the backbone of a modern, efficient, resilient electric system. When these transmission projects are delayed, it's not just infrastructure that suffers, it's everyday consumers, economies, jobs, and even our national competitiveness. In this webinar, we'll unpack how postponing transmission development raises costs, shrinks benefits, and limits our ability to meet tomorrow's demand. I'm joined today by four very qualified people to talk about this. We have Karen Honoran, who's president and CEO of the Electricity Consumers Resource Council, ELCON, where she advocates for policies benefiting large industrial consumers of electric energy before FERC, the Department of Energy, and North American Reliability Corporation, and even Congress. Prior to joining ELCON, she was Director of Federal Regulatory Affairs at the Edison Electric Institute. We also have Larry Gastiger, who is the Executive Director of WIRES. He oversees the International Trade Association's initiatives to advance investment in high voltage transmission. He works closely with members to set and pursue the group's regulatory policy agenda, and he takes a leadership role in promoting the importance of a robust and resilient grid. Next, we have Jeff Daniels, who's currently the Executive Director of the Electricity Consumer Alliance. Jeff is a nationally recognized expert in energy and climate policy, as well as law, with over 20 years of experience in the public and private sectors. Throughout his career, Jeff has developed and led the execution of effective regulatory, legislative, and legal strategies to improve competition in wholesale electricity markets. And certainly last but not least is Zach Zimmerman, who's the Research and Policy Manager for Grid Strategies, where he's focused on economic and regulatory analysis related to power markets and transmission. He is facilitating the Advancing Modern Power Lines, AMP, coalition to support the deployment of high-performance conductors on the grid. And he also supports the Working for Advanced Transmission Technologies, WATT, W-A-T-T, coalition's policy and advocacy work. We certainly have a very qualified panel and with a wide view of the topic which we're going to talk about. So to get us started off, I'm going to ask Zach to do a little presentation that he has made to get us in the right mind frame, if you will, of where we are in transmission and some of the challenges that we're facing. So Zach, if you'd share your screen that is, and we can get started.
Yes, thank you, John. All right, I think I should be showing slides here if everyone can see it.
We see it.
Great. So part of the impetus for this webinar is a report that we released in conjunction with the WIRES group and Larry, quantifying the cost of delaying transmission. So I'm going to run through at a high level some of the results from that report, and then I think we're going to get into a little discussion afterwards. So just to kind of set the stage for this, some previous work that we've done at Grid Strategies looks at the current load growth environment in the United States. I'm sure it's not a surprise to anyone at this point, but forecasted 5-year load growth is up sixfold from just 3 years ago. This represents a 20% increase in national peak load, or the equivalent of adding 15 New York cities to the grid over the next 5 years. So this is a significant change from where the industry has been in the last 20 years and is going to require a lot of new transmission to add enough capacity to connect these industries, these new industries, data centers, and manufacturing facilities to the grid. However, at the same time that we're seeing significant increases in load growth, we have not been building enough high capacity transmission. So some of the high voltage, high capacity lines provide the highest benefits to consumers. They deliver power at the lowest cost. And we've seen a significant decrease in the amount that's been built over the last 15 years. We may be starting to see that turn around as planned transmission lines are increasing, with load growth being a driver of that. However, when you're building large scale transmission, there's numerous opportunities for delay. So there's a lot of complexity within the engineering, financing, planning, and construction. And there are also challenges that are kind of heightened by the number of stakeholders and entities involved. There's federal, state, and local authorities and jurisdiction that may be overlapping and has to be navigated. And then there's many stakeholders who are interested in the process of developing large-scale transmission lines. So the result is that there are numerous opportunities for delay to transmission, which was part of the purpose of this report. So what did we find? We found that the cost of delaying large-scale transmission is very significant to consumers. For every 1 billion invested in these large-scale lines, uh, the delay cost consumers 150 million to 370 million in lost net benefits, so foregone benefits from the line. These delays also impede job creation, they can slow economic growth, and may impact national security. So, the other important thing to remember is that each year that a line is not energized or delayed, is some of the largest benefits just due to the time value of money. Near-term benefits are much more highly valued to consumers today rather than ones down the line. Um, so to come up with these results, we looked at 8 transmission portfolios from across the country. Um, each of these studies represented significant transmission investments and thousands of miles of new lines. And from those portfolios, there was extensive benefit cost analysis that were studied. We took those benefit cost analyses and took the total benefit annualized net benefits from those studies and essentially converted it to a 1 year delay. So our report essentially says that if you delay the entire insert like energization of the portfolio by 1 year, what is the foregone benefits that consumers would experience? Um, and so what we found is that the report or like that these benefits are mostly economic and reliability benefits that arise from the cost of delaying transmission. So a significant portion of the benefit comes from reduced production costs. Adding new transmission allows for more efficient operations of the transmission system overall, access to lower cost generation, lowering in congestion, fuel savings, and other reductions in varying variable operating expenses. The other benefit that accrues over time is the ability to reduce capacity for overall capacity margin. So you may be able to avoid or defer generation investments because transmission allows you to access a wider geographic area and access generation that may have variability in the time that it's generating. Um, for both of these categories of benefits, if you delay transmission, they're not recoverable, particularly for operational savings, since they don't accrue retroactively. So, and then on the reserve margin side, delaying transmission can lock in higher cost generation investments that are required to maintain reliability and resource adequacy. Beyond these specific benefits, we also found that there can be delays in jobs. For every 1 billion of delayed transmission investment, we estimate that there's an deferred 11,000 to 25,000 direct, indirect, and induced jobs. So some of those jobs are directly associated with the construction of transmission projects. However, the added transmission capacity also allows for new generation to come online. So there are construction jobs associated with that. And then the additional transmission capacity, because it can lower prices or just allow for new headroom, uh, allows businesses to grow, can allow things such as data centers and new manufacturing facilities to connect to the grid. And though that represents additional jobs and economic growth that can be deferred or lost if the investments are not made. So that was a quick summary of the report, and we can leave it there. And I think we'll get into some of the details as we go into discussion. So thank you.
Thank you very much, Zach. That was interesting. And in the time for the last year or two that I've been following transmission, frankly, I didn't understand or know what these costs were from delay. And I think we can add on to what you just presented. Larry, I've got a question for you. Wires just had a recent report, and that report says that some of these benefits are not just delayed, but sometimes they're lost forever if a project isn't placed into service as planned. Um, in talking to policymakers and investors, how does this permanence of lost benefits influence how policymakers should really think about transmission timelines?
Yeah, well, first of all, John, thanks to you and your organization for asking Wires to participate in this discussion. Really appreciate the opportunity to engage. I also want to thank Grid Strategies and Zach for their hard work on the report that you just referenced. I think it highlights an issue that has become of increasing importance within the last, I'd say, year and it's only going to get more attention going forward, which is the broader question of affordability when it impacts uh, customer bills, our energy infrastructure. A lot of times we think about it in terms of the upfront costs associated with building some of this infrastructure, and I think that's where you're tending to get most of the focus right now. Um, but this report highlights another aspect, I would say, with respect to affordability, which is how much does it cost if we don't do this investment right now, if we don't build this infrastructure now, but kick the can down the road and try to deal with it later on. And as Zach's report highlights, we actually are seeing an increasing trend of decreasing investment in and building of infrastructure over the last several years. So we're already in that mode right now, and I think we're starting to feel some of the consequences of it. From a policymaker standpoint, I think this report really highlights the phrase I'll just use is that from a regulatory perspective, time is of the essence. We have to get moving on looking at ways to accelerate the building of this needed infrastructure and decrease the hurdles and the obstacles to getting it done. Uh, Look, it takes now any 10 years roughly is the benchmark most people use. Some of it might be less. My fear is actually that that benchmark may be moving out a little bit further than where it is normally thought to be. 10 years is an awfully long time. And what we're also seeing is that little delays and derailments in that timeline over the course of 10 years has an amplifying effect. It actually pushes it out even further. So, such that a 1 year delay for one reason might mean it's actually more of a 2 year delay because it has cascading impacts on the timeline, right? And the consequences of this are pretty clear from the report, as Zach indicated. There are real costs associated with the benefits to customers, whether it's from a reliability standpoint, whether it's from getting reducing congestion so that you can get access to cheaper electricity, whether it's getting the benefits associated with having cleaner energy resources integrated into the grid. All of these things have consequences. And then on top of that, we often forget this investment and this build out actually creates jobs, and not just the direct jobs associated with building it, but a whole host of indirect jobs that flow from it. All of that stuff gets delayed and pushed down the road. So I guess my main message to policymakers is we've been discussing this issue for years, literally. And I think there's a growing appreciation of the need for reducing timelines to get things moving. But frankly, the time for talking is done. We need to actually start having some actions moving forward on this and concrete steps that help reduce um, the timeline for generation. I don't think there's a silver bullet to this. There are a lot of different components that go into it. So it's going to take a major effort. But I think we all have to work towards making progress on that objective. And with that, I'll wrap it up because there's plenty more I can say, but I know that my colleagues have a lot to say as well.
Oh, thank you for that. That could probably end the webinar right now, except we don't have the answers to the problem yet. So a little more on the problem definition. Zach, getting back to you in the slides you presented, um, I think there's a misunderstanding in the general public at large and how these things affect them because I've read a lot of things, and when I was in the legislature, people complain about their electric bills. So how does it really translate to consumers, and what's the best way that we can educate consumers about what these delays do to them, and if we don't delay, what it does for them?
Yes, thanks, John. And Larry touched on this a little bit as well. When you look at as Larry said, there's a lot of discussion around affordability today and what that means for consumers. And most of that focus right now is often on those upfront costs of transmission or generation, and because they have very large price tags. Um, what this report tries to quantify is the cost of inaction, which is often a much harder uh, a- thing to quantify and also to message around. And so the report looks at, if we were to take those investments and delay them or not have them materialize at all, what are those impacts? And what we find is that transmission allows for the numerous benefits that Larry talked about: reduction in congestion, lower production costs, all of those things. Those have a bigger impact on your bill in form of the generation component. Generation is almost around like 2/3 of your bill, and transmission is much lower than that, maybe around 15% of your bill. So when you're adding new transmission, it may increase the transmission component of your bill, but you're seeing much larger reductions in the generation component on an electric bill. Uh, our report quantified the foregone benefits that we see. The other piece that we didn't really talk about is we provided some examples, but there isn't extensive data on this. But essentially, costs, the actual increase in the cost of the transmission project when it's delayed. So you can see these costs increase from additional material, labor expenses, engineering, or legal fees that arise when you delay a project. One example of this comes from Cardinal Hickory Creek. This was a line planned in MISO in the Midwest as a part of the MVP projects back in 2011. It was initially scheduled to go online in 2021, but there was litigation that led to about 4 years worth of delays. Those 4 years led to an increase in the project cost by about $200 million, which is approximately a 25% increase in the project costs. So um, another example of this is New England Clean Energy Connect. This line was also delayed by about 5 years and led to project cost increase of around 500 million, which is a 50% cost increase. So not just our benefits in terms of lower cost energy foregone by delaying transmission, but you also just see the cost of the projects rise as well, which we didn't quantify in the report, but it's important to remember.
Those are some pretty big numbers. Um, I don't live in either one of those areas, but I'm sure that here in North Carolina, I've got similar issues going on. And quite frankly, I don't like it because I'd rather pay less than more, as I'm sure that every other consumer would like to do. So, staying on the issue of consumers, Jeff, we're going to turn to you, and we're talking about transmission bottlenecks in different regions of the country. Consumers have different opportunities to choose generation on a competitive basis or not. And I know it varies region to region. So these transmission bottlenecks, do they also limit consumer choice or prevent access to competitive forms of generation for the consumer?
Sure. Well, thanks. And thanks for having me and really appreciate the opportunity. These conversations are so important to make sure that we're thinking about our transmission expansion needs in a way that's really customer centric. So thanks to everyone for the work on this report and for teeing up this conversation today. You mentioned costs, and I want to talk a little bit about costs, and then I'll talk about customer choice and competitive generation. The best way to really zoom in on the cost implications to customers is to go back to that important graphic that Zach showed in his presentation that illustrates how transmission congestion causes real world cost increases on consumers and limits their ability to access new competitive sources of generation. So, when we talk about transmission congestion, we're just quite simply talking about areas where a lack of transmission capacity prevents the most economic electricity generating unit, the most economic supplier, from flowing their electricity to customers. That could either be because there's no transmission at all, or because we have lines that are undersized, or we have situations on the grid that create congestion that could be alleviated by additional investments. All of those things can prevent generation resources from reaching customers. And electricity systems are operated to produce the lowest possible cost for the production and the delivery of electricity to consumers because, as you said, we all want to pay less. And so grid operators around the country do this by utilizing what they call a security constrained economic dispatch. And that's just a fancy way of saying that we turn on the generators that are the cheapest, that produce electricity at the lowest cost, unless grid constraints prevent us from delivering electricity from those low cost generators to customers. And in that situation, what the operator has to do is turn on another more expensive generator. And quite obviously, that produces added costs to customers, prevents customers from accessing the generation they thought they were going to be accessing, and creates those additional costs that could be avoided. The map Zach shows on the slide is one of my favorite illustrations of this problem because it shows where transmission congestion is occurring and the magnitude of it. So the darker those red lines are between those 2 points, those are two, rough approximations of points on the electricity grid. And then those lines between them, the redder they are, that means the higher level of congestion costs that customers experience between those points, meaning there were more instances in which the least cost generating resource couldn't reach customers because of a lack of transmission. And one thing you notice, and I'm sure we'll talk about this as we move on, is that a lot of that kind of congestion is between points in different regions, which really shows both how interregional transfer capacity constraints can harm customers and the value of making those kinds of investments to overall customer costs. And so as we talk about this, you also see, obviously, we express this in terms of price, but it also shows, as we've talked about, how it limits access to competitive generation and choices in generation supply as well. The laws of physics here that require us to redispatch when we don't have enough capacity, really overcome our ability to contract with a wide variety of sources and choose the sorts of generation resources we want to serve customers. So I'm looking forward to talking about some more of those issues. Thanks for the question.
Well, thank you, Jeff. That was very interesting. Karen, we're going to move to you for a minute because what you do is you represent a lot of large industrial customers, and we know that with the president's energy dominance, we're trying to reindustrialize the United States. We've seen companies reshore, we've seen companies expand. I'm not sure that industrial consumers of electricity have a completely different viewpoint on cost, but I think they look at it maybe through a different lens. So, from the business aspect, what kind of risks do businesses face when the grid isn't keeping pace with the demand and our modern needs for power?
Yep, absolutely. Thank you, John, for the invitation, and thank you for the question because I think I can offer a little bit of a different perspective. It's along the same line, but When we're talking about the foregone benefits, we're manufacturers. We make things. We have our own customers that we need to reach and our own revenue that we're trying to make. And so when we're ready to build a manufacturing facility, we've gone through the land acquisition and we've gone through, the hiring. We've got employees and we've got the components and we're ready to roll. And if we don't have the electricity to supply that reliable, inexpensive generation, then we're not able to hook up, and we're not able to hook up in an economical way. And those costs then get passed on to even our consumers, the purchasers of what we're manufacturing. And so there's a massive amount of lost revenue when we see grid delays because that is time that we're not producing. And we talk about employment. So there's the direct employment from construction, but all of those other employees that are then going to run that manufacturing plant that are, there to make the products, those jobs are foregone as we wait to connect to the grid. So that's an aspect or a perspective of what happens when we don't have enough generation or transmission to access. The second part is when we're actually connected to the grid, if we do not have a robust transmission system that is reliable, voltage stability is very important and power quality is very important to manufacturing. We need to have a certain quality of power because we have massive amounts of equipment that need to be run. And so if we don't have reliable grid, that can either ramp down our manufacturing, it could cause damage to our equipment. Should we not get the quality power that we need, we could also have to back off of manufacturing. And it's not simply just a switch that we can, switch back on and say, we're back on. I mean, there are ramp up, and that takes time and that takes money. And so there really is a lot of challenges for manufacturers, both getting the access to quality power and maintaining that quality power through the life of the manufacturing. So there is a lot of foregone benefit and extra cost when we do not have the grid keeping up with the pace of, as you said, the manufacturing reshoring. And just one other quick point I will make. I know that the country in the current administration is maybe backing away from some of the clean energy goals that were laid out in previous administrations. And so people say, well, transmission is not quite as important. We're not having to interconnect all of this clean energy load anymore. We're just going to stick to basics, and base load is going to get us there. But with us and manufacturing, we have contracts sometimes with other countries to supply goods. That within those contracts, we have to supply that with clean energy. And so there are many, many manufacturers that are still seeking that clean energy, and we need access to that clean energy, regardless of what the administrative goals are in the current administration. We have these contracts, we need to produce using clean energy. And so the transmission is still necessary to get us the supplies that we need, making sure we have good quality, cheap, inexpensive supply, and that we are able to manufacture and increase our economic prosperity. So I think it is in the national interest to make sure that our grid is keeping pace with the pace of commercial and manufacturing and data center and just all of the innovation and technology of the 21st century. The grid has to keep pace with that.
Those are all great points you made. And the point you made about long-term contracts that companies have oftentimes with overseas countries and other companies in clean energy. When this is done today, I'm going to go back and look at the tape, and I'm going to print that out and take that with me next time I'm in DC talking to congressmen and senators, because I'm serious about that because I think it gets left out of the conversation too much, that it's not about any form of energy just for the sake of it, that there are real life business considerations that should be taken into account when we're making policy. So thank you for that. Larry, we, we've defined the issue here, and quite frankly, it's been not a downer so far, but a little bit of one because we're talking about cost increasing and things like that. So I'm going to give you the opportunity to maybe go down a little bit more and then start us on our journey back up to how we're going to solve these issues. So the first part of that is if we fail to address these transmission issues in the next 5 to 10 years, what's at stake? And then from there, we can start advancing towards good news, perhaps. What's the opportunity for this country if we actually get it right? And real briefly, how might we execute the policies that we need to get it right?
Sure. Well, as to the first part of your question, I think we've kind of touched on quite a few aspects of the question in terms of what the consequences are of the failure to get it done. On a granular level, it's potentially increased risk to reliability of the system. We have the potential for delays in benefits from integrating clean energy resources, as Karen referenced earlier. We have the potential for increasing costs as we're seeing demand rising as well. And then taking all of those and what does that mean on a broader perspective? Well, I do think it starts to affect and become a drag on the country's ability to become competitive in the world market. It will affect the ability for the country to generate jobs so that our domestic economy remains strong. So it has all of those broader implications, which I think actually are part of what's underlying this focus of the current administration on the need for energy dominance and the strong drive to help integrate new, very impactful technologies like AI and accommodate data centers. So those are, I think, some of the potential risks associated with not dealing with this and continuing to kick it down the road for another 5 to 10 years. Now, all right, let's flip it onto the other side. What are the potential upside if we were to actually start focusing on this now and dealing with it today? Well, I'll start with the notion that what we're talking about is a significant amount of capital investment in very expensive infrastructure that actually lasts for a very long time and can get benefits out of it from a very long time. If you look at what the current transmission system is today, the bulk of it was actually built back in the 1950s and 1960s. So, John, that infrastructure, if it was a person, would be ready for Social Security or Medicare about now, right? And some of it actually goes back even further. I've got members in my organization who have infrastructure, transmission infrastructure that was built in the 1920s. So we're talking about 100 years. Now, that's a long time to have investment in infrastructure that we've been benefiting from all of that time up to today. Okay. So if you start thinking about that from the backward perspective and looking at it now, if we start making that type of investment that we're talking about today, it will have significant beneficial impacts, not just for those of us who are in the country today, but for generations ahead. And the ability to make that investment that will not just help our country today, but benefit our children and our grandchildren going forward is a huge opportunity that we simply have to take advantage of to put the country in the best spot to deal with its position in the world and build up a very strong economy for today. So how can it be executed? There's a whole bunch of different ways to go about doing it in terms of like streamlining processes. We've talked about how we can try to reduce timelines on permitting and siting for infrastructure. We've talked about how we can help accelerate investment in transmission to reduce the risks associated with it and to encourage more investment in needed infrastructure. There's no real silver bullet for dealing with all of these. It is actually going to take a number of different policy approaches. So the sooner we get started on all of these different tracks, the faster we're going to resolve them and get moving on building this infrastructure that we have to get done.
That's good. We went down and now we're coming back up. So building on that, coming us back on a positive route, I'm going to move to Zach. And Larry mentioned a couple of things we need to do. I've got two questions for you first. And by the way, for anybody listening to this, feel free to put your questions into the chat. We have one there from Suzanne Teagan. Says, I believe it was one of your charts talking about jobs. That's a lot of jobs. What's the time frame for the D, I jobs? That was one. And if you can answer that, and then, you've done a lot of study on what type of policy or regulatory changes would have the biggest impact. So just give us some insight on which ones, either policy and or regulatory, would have the biggest impact in speeding up transmission development.
Sure. Well, on the first question related to jobs, I believe most of the studies we looked at tended to have a 20-year time frame. Though if you're thinking about direct construction jobs, those are obviously front loaded at the beginning of the transmission project. And to Larry's point, a lot of these studies we look at or that we have are inadequate in terms of how an actual transmission asset is used and the lifespan that it actually has. Many of the studies we have only go out 20 or 40 years. And as Larry said, some assets are in service for 100 years. So yes, the time frames are for those jobs is around 20, maybe 40 years, but they can be much longer. On the policy and regulatory front, Larry touched on a few of these issues, and I'm sure other panelists have ideas as well. So they should feel free to jump in. I agree that there is no silver bullet. We've talked about at Grid Strategies. We kind of talk about the complexity of transmission development and put it into the three Ps: so planning, permitting, and paying for transmission. And there's numerous actions I think under each of those categories that we can really that could be changed and would improve the development and certainty around transmission build out. So on the planning side, a few years ago, Order 1920 was issued, which is a long-term regional transmission plan from the Federal Energy Regulatory Commission, or FERC. Some of the compliance filings for that rule are starting to roll in. So a focus by the administration on ensuring and acting on those compliance filings is something that can be done. We also right now don't have a similar rule for interregional planning. So that is something that action could be taken on that. There's been numerous proposals within Congress around planning at an interregional level. That would get to the point that Jeff highlighted about some of the most beneficial lines related to congestion are the connections between regions. In terms of paying for transmission, there's numerous ways that we can figure out who pays for it. There are, again, some proposals within Congress around kind of standardizing or clarifying benefit definitions. Again, for interregional transmission, that's something that we don't necessarily have a framework for today. There's also things like investment tax credits for transmission that could be beneficial. And then there are some existing tools like the Transmission Facilitation Program or other grants and awards within the Department of Energy that could be focused on and awarded to transmission projects and could be beneficial. And then on the permitting front, this is obviously front and center, I think, in Washington, D.C. right now, with many bills moving through Congress and discussions happening there. So there are specific permitting actions that could be taken to create more certainty around timeline, like improve certainty and speed up timelines related to permitting of transmission. And then there's also the option to create primary siting and permitting authority for interstate high voltage transmission lines, similar to what exists for natural gas pipelines. So those are some of the options. As I said, I'm sure my other panelists have some policies that they would like to highlight as well.
Yeah, that is a long list, and I do want to ask that question to Jeff and Karen as well. That you agree with Zach? Disagree? That's something he forgot? Something he overstated? I mean,
I
Karen?
have I have one. And this it maybe is counter to the talking points today, but there is this understanding that and really how we designed our transmission system is in a very, very conservative manner because reliability is absolutely paramount. And so grid planners and grid operators plan with a lot of additional headroom just for those contingency issues that may come up. They have the necessary capacity to then, bring on the generation or whatever is necessary. Those are, maybe how many hours out of a year. There is a lot more capacity on the grid than we're currently using. And so before we go down the path of a lot of we still need it. Don't get me wrong. We still need expansion of our grid. But, as Larry talked about, that timeline can be 10 years. The data centers, the manufacturers, we're coming now. We need that power now. And there actually is some room on the transmission system that we have today. And there are various technologies and programs right now to better understand how much of that grid capacity we still have available to us and when we can use it. And so one of the ways, as we're waiting for the really expensive and time-consuming build to happen, there are opportunities, relatively inexpensive opportunities right now to really get our hands around how much capacity we have available on the grid to use today, and how do we make sure that we can then use that capacity reliably. So we talk a lot about grid enhancing technologies. These are things that we can do now, either being able to look at our system and like the map that Zach showed earlier with the congestion costs. We can take a map like that and we can reroute energy so that it is meeting and avoiding these bottlenecks. There's all kinds of different technologies. So that is one that I think is not so much about expanding the network we have now, but really using it to its full extent. And I just really have to emphasize of Zach's three Ps. I have it, well, maybe it's because I represent the customers, but the payment part is the part that I think is really impacting how quickly and how efficiently we are developing our grid today. Cost allocation, even I would say above siting and permitting, is the biggest impediment to building our transmission system today. And I think as consumers, we have to have a better understanding and a better appreciation of the benefits of a robust grid. So when we talk about beneficiary pays or cost causers being the ones that really need to be paying for all of this infrastructure, I think we need to take a bigger view about what the grid does for us. And I know as consumers, we see that price tag on our bills and we freak out because it's a big number. But understand, as we were talking about, as Larry mentioned, we are still going to see those benefits 50 years from now. And so when we see cost allocation and we're talking about paying for this, we really need to understand the benefits, and we need to take a broader look at just what a robust grid will do for us in the generations to come. So I think it's something that we need better messaging and better discipline around on this cost allocation, because I really do think this is one of the fundamental fights that really holds up progress on transmission development.
Thank you. Jeff, you were leaning forward like you just wanted to get in there. So now's your chance.
Sure. Yeah, oh good, I'm not I thought I was on mute, sorry. Yeah, no, I wanted to kind of emphasize a couple of things there. A lot of great points were made. I do think that anything that we can do to streamline and accelerate those permitting and siting processes is really important. And to think broadly about the range of things that we can do in that area, whether it's better coordination among federal agencies to speed up the federal agency process, whether it's creating new processes that invite state and local entities into a unified process to work jointly with federal permitting entities to provide a more streamlined process, reduce duplication of environmental documents. All of those kinds of things are really important, and I think it's important to think broadly about the number of different things we can do in the siting and permitting area to speed up our timelines and really focus those processes. The other thing I would mention is really making sure that we have a lot of different opportunities for investment. So, are there ways in which we can reduce the pressure on those cost allocation challenges that Karen talked about? She's absolutely right. Cost allocation is a primary barrier. It's also one of the hardest things to sort out among customers. What I think benefits you and what benefits me, we disagree on that, and we litigate. And so anything that we can do to avoid those litigation outcomes, FERC is focused on trying to get in place ex ante cost allocation methods so that we've already agreed up front what kinds of benefits we're going to encounter and then how we're going to allocate cost based on those benefits. Those are certainly incredibly important. But are there also ways that we can take the pressure off that process, whether it's encouraging more merchant investment where appropriate, which really allows customers to raise their hand and say, I value that transmission capacity and I'm willing to pay for it and underwrite transmission that way without kind of going directly to rate base. Similarly, what can we do with government financing mechanisms to reduce those financing costs, which can then reduce pressure on the financial aspects of rate making? Zach talked about the transmission facilitation program. That's one tool. Loan financing. Several states have transmission authorities that work not just in transmission financing, but also in helping identify good corridors and pathways within their states for transmission that will reduce permitting impacts. So, a few other ideas of regulatory and policy changes that could really help in this area.
Thanks. Karen, you mentioned something about grid enhancing technologies, and hopefully everybody on the call knows what a grid enhancing technology is, like reconductoring and dynamic line ratings and things like that. Those cost less than new transmission lines, but doesn't costing less sometimes run into investor-owned utilities' basic economic model of wanting to build larger cost things for the guaranteed rate of return? Should we incentivize gets or how do we get utilities to want to do more of that, even though they don't get as big a return on that as they may from building a bigger capital project?
Yeah, and that's an absolute, legitimate question. And Larry and I can get in a room and we can fight it out.
Well, you're in a room right now. Let's go.
I know we're in a room right now. Yeah, and I think that, there is that incentive, that utilities earn money by building. And so there does need to be, um, we want to incent utilities to be able to look at some of these solutions. So I know that Grid Strategies has worked on in the past on something called shared savings, which, should a utility look at, investing in enhancing technology or some of these less expensive technologies, that they would then get a share of the benefits of that to sort of incent them to look into investing into these sort of less expensive, not capital intensive. So again, the returns. I think that, we have to find a good common ground. And I do think that there needs to be a little bit of an incentive, for the utilities. And I know that there are a lot of investor-owned utilities right now who are very bullish on grid enhancing technologies, AEP being one of them that's just really embracing a lot of these. And so I think, working with these utilities, it's imperative for us as customers to communicate to our utilities how we see the value in this, and work with them to see the value in investing into some of these technologies for their consumers. But really want to hear some ideas from Larry about what do investor-owned utilities want to see, for them to really commit wholeheartedly in grid enhancing technology. So I'm going to pass it on to Larry.
Okay, Larry, go for it.
Yeah, I think if I lean in forward any further, I'm going to butt my head into the screen because I was ready to go. But I do want to touch on a few of those, and I'll just say, first of all, yes, I do think we need to look at various, I'd say more broadly than just what we've characterized as grid enhancing technologies. There are a host of technologies out there that can be used either to speed up getting infrastructure built or get more out of the existing system than we have right now. I would, I would, I would say so just one caveat on some of this. Not all of these technologies are cheaper than some of the currently used uh, uh, methodologies or devices that we're using today. Some of them are potentially a more expensive upfront cost with, you know, better savings further down the road, perhaps, right? But you have to deal with the issues around the higher upfront cost on those investments as well. And I agree with Karen. We agree with quite a bit, actually. Karen, I agree with you. There's a spectrum of utilities out there. Some are more advanced in terms of using these than others. Some of the technologies, there's always a little bit of a reluctance to wait till they're fully proven, and whatever that means is a bit in the eye of the beholder. So that's a factor as well. So I do think we have to be looking at them. I think there's a lot of issues around the usage of them and the incorporation of them. I do want to add one additional caveat, which is I'm always a bit concerned that GETs and advanced technologies are viewed as the shiny new object in the area of transmission build, and that, oh goodness, we can just use the existing system, and if we use these technologies, we don't need to build anything more. I think most of us realize that that's simply not the case, that we can get more out of this system, but it's only a part of the solution, along with investment and build out of other infrastructure, including steel in the ground. And then one last thing, actually, Wires did do a study on this topic, the one that we did just before the Grid Strategies report we talked about today. It's on our website. It does an overview of a whole bunch of different technologies, how they're being used, and what some of the benefits and the challenges are associated with trying to use those technologies. So I would point people to that study on our website to get further educated on the topic as well.
Well, thank you. That wasn't too bloody. That was, I mean, kind of an agreement. For the last few minutes we have here, there's a couple of questions I'd like to ask, and it to be first come, first served. So the first question is, what specific reliability risks are emerging as electrification and data center growth accelerate, and how do transmission delays make those risks worse?
I might be able to start. Oh, I'm sorry,
Okay.
Zach. Did you want to
No,
start?
go ahead,
Yeah,
Jeff.
Jeff,
Go
go.
ahead.
Sorry, we didn't state any like raise hand or whatever. But I think one of the emerging reliability risks that we see the industry focusing on is data centers are new large loads, and so as we see large loads, if something happens on the system, some kind of disturbance or fault, and that large load removes itself from the system to protect its own equipment. This is how both loads and generators work on the system. when they are larger loads, that can potentially cause greater instability. But all of that is really a factor of having a grid that doesn't have enough capacity, because if we have a grid with a larger capacity with connection to more generation resources and sources of energy in more places, then the impacts of any single load, even large loads, needing to trip offline for some reason, can be diminished. But if we have constrained systems where we don't have enough access to those resources, then we can see those kinds of reliability challenges exacerbated.
Okay. Zach, did you want to comment on that too?
Nope. Jeff said everything that I would say.
Okay.
I would just add that on that point, we know this historically, and this is actually some of the impetus for the creation of some of the existing RTOs today was as power pools initially to help support large loads, because of what Jeff was saying. As you have a more broadly interconnected system, and additional capacity, those fluctuations in loads become more of a blip, more of noise than actual a significant impact on the system.
Okay. There's another question that kind of goes into the same direction. It's like, and the question is, how do you balance the cost to ratepayers of building out transmission that mostly benefits one industry, such as large data centers? Everybody's smiling. Who wants to take that one? Do I need to pick somebody?
I
Karen.
can, I, oh, Karen, go ahead.
You're muted.
Oh,
Yeah.
Yep, I'm muted. Um, yeah, I think, you know, we hear this narrative and it's absolutely a concern with, because we have new large load, whether it be this push to win the AI race. So we need the data centers to make sure that we are advancing the onshoring of manufacturing, the electrification, all of these things that you said, are all contributing to some issues that we have on the grid. I think part of this is, we're working very, very hard on making sure that when a large load comes in, whether it be a data center or a manufacturer, that's a FERC term that we use a lot. The only reason for that transmission is to serve that specific load. Well, then those costs should be borne by that load and not to other rate classes, whether that be industrial load or whether that be residential load. But I think what we really need to start doing is understanding the broader beneficial impacts of transmission. I think, the bigger the pool, the lesser the costs. And I completely understand if a big load comes in and we need all of this power and we need all of this infrastructure to get that power to us, we should be paying for that. But there has to be an understanding that some of this backbone transmission infrastructure benefits everyone. And the more that those costs are spread among a larger class, that does benefit, whether that be through reliability, cheaper generation. Um, that is how we try to minimize the cost impacts because, yes, this is expensive stuff. The reason our power bills today are so high is not because of generation, but mostly because of the distribution and transmission infrastructure that we've been building. And so, yes, it is. The more that we can recognize and really quantify benefits, and this is something that I've been working with FERC with for a while, is how do we really quantify the benefits and understand really who is benefiting from these grid infrastructure development, expansion, technology, and making sure that we're all contributing. So whereas if you can identify it, it's us, we're causing it, that should be borne by us. But I think this country needs a bigger dialogue about the tremendous benefits of backbone infrastructure and how we all should be paying our fair share, and whether that is through some tax cuts or other government funding, we really need to understand as a country the value of transmission.
And that's a great way to
Yeah.
end because we have about 30 seconds left. So I would just like to thank all the panelists today for your great insights and your views. And it didn't get too nasty here. I mean, we had a lot of agreement, so that's good. I would just tell everybody listening, the webinar will be available to view again and pass on. Our comms folks will put that out in the next week or so. Again, thanks to the panelists, thanks to all the listeners today. And from CEN, thank you very much.